Good evening, ladies and gentlemen. We have a large, I think, contingent from the Wissenschaftskolleg here tonight, a Vico contingent, and I understand from Michael Gordon that today is a day of life and death. That is, at Vico they spend most of the time on life and death, and he is hoping he will learn more about it tonight. And so I hope so will everybody else, but we'll see. My function, of course, ladies and gentlemen, is to introduce the person who will introduce Sophia. And I will make that very short. That is part of my assignment, to be short about it. Professor Gordon, who is a professor at Princeton, and who did his undergraduate and graduate work at Harvard, I got his bio from the Vico, and it says, Michael D. Gordon, PhD, Professor of History, Princeton University, born in 1974. May I disclose that? Born in 1974. Yeah, born in 1974 in New Jersey. Now, I have never heard that. I mean, people are born in Princeton or in Passaic or some such place, but somebody who admits outright that the crucial place is New Jersey is rare, and I admire you greatly, Michael, because they must have found that information or gotten that information from you. Professor Gordon teaches history of science at Princeton, and all I need to do tonight is I want to read you the titles of his books. I hope, Michael, that you invented all of these titles and not the University of Chicago Press or your other publishers. But these are titles, as you will see immediately. When you hear them, you have only one desire. You want to go out and buy that book. So the oldest, meaning from 2004, was called A Well-Ordered Thing, Dmitri Mendeleev, and The Shadow of the Periodic Table. And I also learned from Michael today that this year is an anniversary of coming up. When? 2019. Oh, 2019. So you have time to get prepared. So get prepared another 3 years for the anniversary of the periodic table. His next book was called 5 Days in August, How World War II Became a Nuclear War. The third book was called Red Cloud at Dawn, Truman, Stalin, and the End of the Atomic Monopoly. And now we get to the Pseudoscience Wars, Immanuel Velikovsky and the Birth of the Modern Fringe. Now that is a broad topic, obviously, as you understand. The modern fringe seems to be growing and growing and growing. And I would like to know whether you shed any light on that. But now here comes my favorite title of the many. How many have I? How many books are there so far? 1, 2, 3, 4, 5, yeah. My fifth, there is a sixth. Fifth is my favorite title. How Reason Almost Lost Its Mind. The Strange Career of Cold War Rationality. That's a fantastic title. I mean, you should all be jealous. You would have wished to have dreamt up that title. And finally, the newest book just published is Scientific Babel, How Science Was Done Before and After Global English. And that's actually a very interesting question about which we Latinists never think. All right, Michael, thank you.
Thank you, Gerhard. It's going to be hard to introduce Sophia now. I never thought to defend New Jersey in Germany. I have to do it in the US all the time. It's a great pleasure to introduce Sophia Rust, who's Associate Professor at the History of Science Department at Harvard and the Anna Maria Kellen Fellow this spring here at the American Academy. Sophia is interested in the meaning of life. Who isn't, you might say? But she's not concerned with the usual significance of that phrase, which usually calls up ethics or theology. She's interested in life. What does that term mean? Since today we live in an age saturated with sciences and the life sciences, perhaps above all, much of the work today in defining and shaping the notion of life takes place in that realm. Whatever else it also might be, life itself has become, and has been for a long time, a heavily biological concept. Sophia was trained first at Rice University and then at Massachusetts Institute of Technology as an ethnographer, and she looks for meaning the way anthropologists do. The people she studies are biologists, but not exclusively biologists, and I'll get back to that. And they're the ones crafting the meanings of life she's currently interested in. I suppose you could just ask the biologists what they think life is, and you'll get, if you do that, you'll get very formulaic textbook answers that are usually about what the previous generation of biologists said they thought life was. It's not about what life is, it's about what life was, what it meant. If your quarry is contemporary science, you need to do fieldwork, and the point of fieldwork, as Sophia writes in one of her articles, is not to replicate the discourse of practitioners, but to juxtapose what people say with what they actually do in real practice. If you want to see how the very concept of life is changing in the present, you need to see how biologists make the concept of life. Never being one to go by half measures, Sophia watches them actually make life, although perhaps not as we know it. Her first book, which is forthcoming from University of Chicago Press, called Synthetic: How Life Got Made, is the first anthropological and historical study of one of the most interesting ventures in the life sciences today, synthetic biology. Before I say something about what synthetic biology is, which turns out to be hard to do, I should note that Sophia began her field work at MIT just a few years after one of the first labs in the world, the first lab in the world, opened there. So she was there on the ground floor. That means she was able to chronicle the evolving practices of the lab, the weekly lab meetings, countertop experiments, debates, an evolving picture of what the field meant or was supposed to become or be. Is it a form of molecular biology that explores genetic mechanisms using tools and techniques from engineering? Is it engineering that happens to work with DNA? Is it computer science that uses base pairs instead of binaries? Is it dangerous? Is it the future? Is it the past? Is it the origin of life, synthesized in a lab in its simplest possible form? Should standardized biobricks like electronic components be the way we correlate innovations, or not? If synthetic biology were actually engineering, that would be a standard way of doing it. It turns out that fails, for reasons Sophia can tell you. How do we rethink kinship and relatedness when all the genomes are made from scratch? Essentially, every question's up for grabs, and Sophia was able to catch it in the act. As she puts it, quote, life as an analytic object has come undone, such that when life can be manufactured, what counts as life is defined retroactively according to the techniques used to make it. Now that the field is settling somewhat, perhaps, into a variant of what Thomas Kuhn would call normal science, Sophia's history and ethnography of the field is about to appear, which is quite something. This also illustrates her sharp intuition about the questions one should be asking, and that puts her at the center of the most vibrant conversations in science and technology studies, or STS. STS is methodologically diverse, and she deploys all the modes of inquiry, including lowly history, which some of us appreciate, sometimes going quite far back, to elucidate the present moment. But her interest is on science right now. Contemporary science is extremely hard to study. There are no archives, and there probably will never be archives because emails are deleted immediately. The science changes really rapidly. There are a very large number of practitioners, and the work is quite technical. It's also a huge gamble. Who knows whether your field is going to be the next big thing, fade away, be based entirely on fraud? It's entirely unknown. So given that none of the science at the forefront of research right now is settled, there's always something up for grabs, and Sophia looks for that in practices. There's always a risk, given the scale of the phenomenon of contemporary science, that you will look at established labs and established practices. STS doesn't have nearly the quantity of researchers or resources to cover everything, so that will be where you might focus. And that's where lab ethnography started, but Sophia doesn't usually go to those places. She doesn't even stay with people who are usually called scientists. If knowledge is rooted in practice, then diversity of practice is at issue. She has worked on molecular gastronomy, do-it-yourself hobbyist synthetic biologists, people who crochet coral reefs, and projects that seem liminal to science as it would be typically defined. But she's not interested in the meaning of life. She's interested also in the meaning of science, which is how you make it. Her talk today is The Quick and the Dead, Life, Latency, and the Limits of the Biological.
Thank you, Michael, for that very generous introduction. And I'd also like to thank President Casper and John and Tina in the programming office, Yolanda and Laura in the library, who I think I'll miss more than anyone else this year. They're very helpful. The kitchen staff for the lovely meal we just had, and of course my fellow fellows for making this a truly rich and meaningful intellectual experience. And I shouldn't forget also Anna Maria Kellen and the Kellen family for this opportunity. Dutch artist Theo Janssen's strandbeests are fancifully peculiar creatures composed of recycled water bottles, plastic tubing, and sails that draft and drag in the wind. The strandbeasts' herd-like movements, sometimes lumbering, other times scuttling crabwise, are so lively that some writers have speculated as to their life-likeness. Indeed, their creator boasts that they are mobile, responsive, and evolvable, and hence, as he puts it, new forms of life. In an op-ed piece in the New York Times last year, however, Scientific American journalist Ferris Jobber commented that the strandbeast has led him to ask, why is it so difficult for scientists to cleanly separate the living and non-living? He concluded that it is because they have been trying to define something that never existed in the first place. Here, he writes, is my conclusion. Life is a concept, not a reality. It seems that we are now firmly back in Foucauldian territory. And Foucault declared that life itself did not exist before the foundation of modern biology in the 19th century. Before that, as he put it, there were only living beings. Perhaps, if life did not precede the 19th century, neither did it survive the 20th. However, the strandbeast is only the latest example of long-standing efforts from antiquity to now, united by the assumption that life-like processes that are simulated in abiotic, that is, non-living media, produce entities that perform as if they are alive. Historians of life sciences have observed that in seeking to generate theories of life, designers have time and again worked to simulate living processes in non-living things. So think, for example, of artificial life, artificial intelligence, automata, homunculi, robots, and self-replicating cellular automata. And here I'm thinking most famously of John Conway's Game of Life. Each of these are efforts to manufacture inanimate entities that bear the features most closely associated with life, things like emergence, interaction, growth, metabolism, locomotion, responsiveness, and even perception and sentience. I'm sure you all saw the headlines last week that an artificial intelligence designed by Google bested world champion Go player Lee Sedol. However, I believe, following the work of science studies scholars from Donna Haraway to Elizabeth Wilson, that such efforts are rooted in a lurking Platonism that privileges form over matter and action over substance. As anthropologist of science Stefan Helmrich has put it, following Judith Butler's Gender Trouble, artificial life operates as a kind of drag performance. And here I invoke Lady Bunny, who I'm sure many of you are now familiar with, as my paragon. Artificial life is like drag in that drag exposes all gender expression as being already merely performative. And artificial life does the same thing to the category of life, right? All life, perhaps, is performative. In the project I've begun at the American Academy, which is titled The Quick and the Dead, I aim to upend the Platonist assumption that theorizing life relies on animation and vitality, of lifelike processes built into non-living substance. To do so, I focus on biological latency, that is, examples of life that are stopped dead in their tracks, microorganisms that remain dormant for decades, seeds that can be resurrected after centuries or even millennia, billion-year-old fossils bearing traces that are only possibly signs of life. Following such examples, I explore a mirror epistemology in which latent life, whether found in rocks, ice, laboratories, or outer space, allows life scientists to rethink the temporalities at which life proceeds. Throughout, I ask, how quickly must life happen to count as life? What defines life when the animating processes that mark the living slow to imperceptibility, as life de-animates? How is life defined when it is seemingly inert, so no longer a verb, but instead hardened substance in a state of arrested suspension? My analysis of biological latency is organized around a series of antonyms to life. So things like death, non-life, the inorganic, the inanimate, the abiotic, and the immortal. And this evening I'd like to focus on this last example and ask, how might our definitions of life change if the opposite of life is not death, but immortality? So allow me then to explore this question through one of my ethnographic field sites, which is a Norwegian archipelago in the Arctic Circle called Svalbard. And so Svalbard is right here between the 74th and 81st degrees north latitude, so just immediately north of Norway and east of Greenland. In Svalbard, my research was limited to the island of Spitsbergen and the northernmost settlement of Longyearbyen in particular. And my story will also range to two nearby coal mining settlements, the first being Pyramiden, and the second is Nyalesund. And I'll divide my talk into three examples of latency that I found here: virus, coal, and seed. You can't die in Svalbard. You can't be born either. The sick, disabled, and elderly are forcibly evicted and shipped back to the mainland to end their days. The governor also requests that women in their third trimester leave the island. The reason for this policy is twofold. So first, Svalbard is not, as citizens call it, a life cycle community, which means that only adults who are able to work are allowed to stay. And the elderly are told that as few as 20 retirees could bankrupt the entire archipelago. The hospital has fewer than 10 beds and just one doctor. The second reason, however, is climatological. Less than 1,000 kilometers from the North Pole, over 60% of Svalbard's landmass is covered by glaciers. And furthermore, permafrost renders the ground nearly impenetrable. In the 17th century, for example, Russian trappers would leave their dead above ground throughout the winter, as the earth only softened enough to bury them in the spring. And once a body is buried, Arctic temperatures can keep it from decomposing. And if the body is buried above permafrost, it might decompose, but then the thawing ground eventually forces bodies back up until they surface again. So the dead remain fresh, just below the frozen earth, perpetually waiting to be disinterred. I arrive in Svalbard at the end of February, when the sun hasn't risen for some time. In the polar circle, 4 months is spent in total darkness, and then for another 4 months, the sun never sets. And this is called midnight sun. So technically, the sun rose about a week ago, but at this time of the year, it never climbs above the mountains on the other side of the fjord. During this perpetual twilight, a prolonged late morning sunrise gives way an hour or two later to early afternoon sunset, staining the mountaintops pink. It's not overcast, really. The light is limpid and the sky is cloudless, but the sunless half-light makes every hour seem untimely. Okay, so the first part of my story is about virus. The cemetery is surprisingly hard to find. With Advent Fjorden on my right, I first walk to the church, its red wooden spire visible from across the frozen river valley that cuts northwest of town, which is accessible only to those on snowmobiles or dog sleds. The church, like most other things in Longyearbyen, boasts being northernmost. A few examples include the northernmost airport, the northernmost newspaper, and the northernmost sushi restaurant. I circle the church once, but no cemetery is visible in the bare ground surrounding it. The administrator I meet in the church nave blinks quizzically when I ask for directions to the cemetery, and then directs me 300 meters along the Plateberget mountainside. Don't cross the bridge, she says, and don't pass the White House. But 3 times I mistake fields of wooden stumps for the cemetery. These narrow wooden poles cant acutely from the ground, a kind of German expressionist gesture toward a cemetery. I later learned that these are the piles on which the original homes of Longyear City were built in 1906. German forces shelled and burned them during World War II, but they're still here. I nearly missed the actual cemetery, though, unable to see it until I'm already there. The rows of white wooden crosses are barely visible against the snow-covered mountainside. No one has been buried here lately. The highest row of gravestones mark the graves of 7 miners who died of the Spanish Lady, as the 1918 flu was then called. Now, the very young and the very old are usually hit hardest by the flu. Yet World War I cultivated one of the deadliest viral strains in history. As young men marched across Europe, the so-called Spanish flu preferentially culled young adults. And the results were devastating, a horror show of pandemic epidemiology, clutching at the coattails of military maneuvers and socio-political ruin. 40 million people died of flu during World War I, surpassing the casualty rate of both combat and genocide. On September 24th, 1918, 69 young men, most of them fishermen or farmers, traveled on board the Forset from the Norwegian mainland to work in Spitsbergen's coal mines. In the 3 days it took for them to sail from Tromsø, which is the northernmost port, to Longyearbyen, every last one of the passengers fell ill. 7 men died within weeks of their arrival. The oldest was just 28 years old. Their deaths are recorded in the diaries kept by Stora Norsk, which was the local coal company that had purchased Svalbard mines from the American-owned Arctic Coal Company just 2 years earlier. Stora Norsk buried them here, on this stark and desolate hill overlooking a town they would never see. Presumably to save money, their bodies were wrapped like fish in last year's newspapers. The bodies of the 7 miners remained frozen beneath Plateberget Mountain for 80 years, until forensic pathologists and archaeologists, armed with new DNA sampling technologies, arrived in Longyearbyen to find out whether the flu virus that had felled them was still biding its time in the Arctic tundra. Researchers had already tried to exhume victims of the 1918 flu in other parts of the Arctic Circle and Iceland. So as early as 1951, microbiologists had traveled to Brevik Mission near Nome, Alaska, to exhume bodies from a mass grave of Inuit flu victims, though they were unsuccessful in this endeavor. 50 years later, after exhuming 6 of the 7 bodies in Longyearbyen Cemetery, Canadian medical archaeologists sampled soft tissue using a boring device that had originally been developed in forestry for taking tree core samples. This human tissue would have long since putrefied in bodies buried in warmer ambient conditions, but in Longyearbyen, they were desiccated and frozen solid. 100 samples of lung, liver, kidney, and brain were dissected from the bodies. The genetic material of the 1918 flu, researchers found, was still there. Bits of ribonucleic acid, or RNA, fragmented in the bodies of these Norwegian fishermen. The bacteria clinging to the inside of their lung tissue was still alive, and researchers cultured it, and it grew heartily in nutrient broth when heated to body temperature. Biotechnical resurrection has always been a frosty enterprise. Such climactic conditions enable what historian of science Hannah Landecker has described as one of the foundational tools of biotechnology, namely the suspension and resumption of biological time. In the first decades of the 20th century, biologists learned to freeze and thaw microbes and sperm. In the 1950s, some experimented with reanimating hamsters. And by mid-century, they had moved on to human tissue. The cultivation of tissue culture and cell lines made possible by careful calibrations of time and temperature made cells some of the most useful living tools of experimental biosciences. Living material had become temporally extendable and suspendable. The word for these biotechnologies, I should mention, is immortalized cells. In the 1960s, Robert Ettinger built on earlier research freezing human tissues to pioneer cryonics, freezing dead humans' brains, or sometimes whole bodies, in hopes of their eventual reanimation and subsequent immortality. In her history of tissue culture, Landecker describes the material infrastructures that enable the proliferation of cells and tissues outside the body. Cryobiology, she writes, has long been a technique of managing biological reproduction. All the disassembled generations, the novel simultaneities, the gaps of time between death of one generation and birth of another, with a suspension of continuity between them, all of these deeply unsettling temporal disruptions depend to some degree on the rather banal presence of a working deep freeze. But such disruptions, while revising what counts as biological, also entails a further reworking of life. As biological processes cease in extreme cold, biologists redefine life not as a process, but rather as organized structure. Put otherwise, biological latency joins time to temperature, so that the slowing of living processes gestures toward the pausing and resumption of biological time. 7 years after the bodies were exhumed in Svalbard, the genetic sequence of the extinct virus was revived, not from the Svalbard samples, but from a different piece of human tissue kept frozen in a pathology archive in Washington, D.C. The sequence was confirmed using one of the bodies that had been preserved in the mass grave that I mentioned earlier in Brevik, Alaska. That year, the entirety of the sequence of the 1918 flu was published in Nature and also online. And researchers at the CDC in Atlanta sprayed the virus into the noses of mice, all of whom died within days. The Spanish lady's resurrection ignited a furor among biologists and ethicists who were horrified by how easy it was to revive this latent flu. They worried that a bioterrorist could easily download the sequence from a public database, order the virus from a DNA synthesis company, and then have it shipped back via FedEx. But what does it mean that newspapers and science journals report, in their words, that we are now haunted by the specter of a virus that lived, died, and was brought to life again? Attending to creatures that can be arrested and revived reorients definitions of life away from the continuous unspooling of living phenomena from one generation to the next. And I argue that freezing does not simply pause, reverse, or restart biological time, but grafts the past onto the present in order to capacitate future life forms. Okay, the second part of my story is about coal. Longyearbyen is named for John Monroe Longyear, an American capitalist whose name already suggests a kind of temporal slackening. Longyear arrived in Svalbard and saw riches in the plentiful coal seams that marked the land, a Triassic gash just beneath or even on the Earth's surface because glaciers had carved away the mantle above it. Coal is, of course, dead organic matter. All that shiny black sediment is the detritus of amphibians, fish, scorpions, and ferns that flourished in the swamps of a once tropical Svalbard in the Carboniferous eon, the dead tissue inspissated by heat and pressure until all that latent energy condensed into something combustible. Longyear's Arctic Coal Company began operating in 1906, and its first mine was dug into Plateauberg's slopes, directly above the graveyard, though the graveyard wasn't there yet. Coal mining culture persists among citizens of Longyearbyen, recognizable in the small daily rituals of the townspeople. So, for example, taking off your snow boots in the mudroom before entering homes and businesses is a throwback to the days when miners avoided tramping coal dust indoors on their shoes. Many citizens carry slippers with them to wear indoors, and schools, museums, and hotels provide pairs of communal shoes that guests can borrow. One night I had dinner with a Norwegian paleontologist who's in town to lecture at UNIS, which is the local university. He first visited Longyearbyen as a teenager to work in the mines. And he points out the window and across the street to the building that now houses a coffee shop, an outdoor clothing store, and the local library. So this building here right behind the statue of the miner. That used to be the company sauna, he explains. At the end of each day, miners would strip off their dirty clothes and steam themselves clean before putting on their evening clothes. And every morning, they went through the same ritual in reverse. Today, coal mining in Longyearbyen is largely shuttered. Coal mining infrastructure, however, remains scattered across Longyearbyen's landscape. The dark skeletal remains of coal tipples, lift systems, and aerial tramway conveyors litter the surrounding mountains, looking much the way Stora Norska left them. They resist decay because the temperature is too cold for liquid water to rot raw wood. So they're ruins, but they will remain so indefinitely. Across the fjord from Longyearbyen is a ghost town called Pyramiden. The closest I get to Pyramiden is by visiting the Longyearbyen Library. There, I learned that Pyramiden was a Soviet mining town that was abandoned to the elements in 1998. Pyramiden was designed to conquer the formidable climate of the high Arctic. So miners could swim in a saltwater swimming pool, eat from a greenhouse that grew cucumbers and herbs, and walk across specially cultivated green grass that was designed to be hardy enough to flourish in the town square. The city also boasted a basketball court, a library, a nightclub, and a museum, among other urban conveniences. 10 years after its closure, 2 archaeologists and a photographer documented the ghost town after a decade of neglect. They found there what they described as a weathered and blasted antonym of the modern. In their words, ruins such as Pyramiden have their own historical mission. They rescue a forgotten past, not as heritage, at least not in any ordinary sense, but as a kind of involuntary memory that illuminates what conventional cultural history has left behind. They bring forth the abject memories that this history has displaced. When the Longyearbyen Library closes later that night, I cross the street to sit at one of the 2 bars in town, drinking beneath Lenin's steely gaze. And I ask the bartender what she knows about this bust, and she shrugs and says, somebody found it over in Pyramiden a few years ago. But what is a ruin? Let's page back to Walter Benjamin, who in his 1925 habilitation, The Origin of German Tragic Drama, described history as a petrified primordial landscape, that is, nature frozen or turned to stone. For Benjamin, as he looked out at the ruins of Europe, an architectural ruin was an allegory for history, a history that, he pointed out, is millennial but not dialectical. Phrased somewhat differently, history is a perpetual caesura history is a perpetual catastrophe occupying the caesura between past and present. Now, here it's worth remembering that Benjamin triangulated between history, life, and ruin, as all 3 were temporal allegories for one another, right? Ruins fall apart, life decays, and history tends to tragedy. More so, life and ruin were, for Benjamin, also allegories for allegory itself. So as he put it, allegories are in the realm of thoughts what ruins are in the realm of things. Ruins in Svalbard are not allegories for life, perhaps, as much as they are allegories for latency. Anthropologist Ann Stoller suggests a renewed attention to places of ecological catastrophe, such as Agent Orange-infested landscapes of Vietnam, as the hazardous waste and former nuclear test sites of the Bikini Atolls, as the defunct sugar mills of Central Java. Such places, she asserts, condense alternative senses of history and are at once products of the past imperfect that selectively permeate the present as they shape both the conditional, subjunctive, and uncertain futures. And speaking of uncertain futures, Longyearbyen is now a coal mining town without a coal mine. Its miners are out of work. So an influx of scientists has begun taking their place, propping up a zombie economy with research grants from nations around the world. And recall that I mentioned earlier a nearby Svalbard coal mining settlement called Ny-Ålesund. The coal mines there closed after an accident killed 21 miners in 1963. But today the town enjoys a second life as a research station. Each coal miner's cabin now belongs to a different nationality of scientists, and the Chinese station is the oldest. These scientists arrive in Svalbard in perfect irony to observe anthropogenic climate change. As all that coal combusted, atmospheric carbon dioxide levels rose, and the glaciers, whose tongues and feet and snouts had waxed and waned along depressed arêtes for hundreds of thousands of years, began receding. As their mass balances shifted, they calved and let loose, and the temperatures rose, and the waters rose, and the temperatures rose again, unleashing a terrible positive feedback cycle. The third part of my story is about seeds. What will become of life then as these glaciers recede, as the climate warms, and ecological catastrophe joins geopolitical catastrophe to make this and every other place precarious and unlivable? In 1984, agricultural researchers from a Norwegian university decided to conduct what they termed a 100-year experiment. So what they did was they gathered a small collection of seeds and stored them underground in mine number 3 on a Plateberget pass just beyond the Longyearbyen airport. The interior of the coal mine maintains an ambient temperature somewhere between minus 2.5 and minus 3.5 degrees Celsius, which is far enough below freezing that they suspected the seeds would be naturally preserved within the shaft. They checked on their seeds from one year to the next, and they still do so, finding them in a state of suspended animation. To this day, not a single seed has germinated. The Norwegian scientists proposed to the Food and Agriculture Organization, or FAO, of the UN that there was plenty more room in the mine shaft, and perhaps for a small fee, other countries would want to archive their seeds for preservation in this naturally occurring cryobank. The UN turned down the proposal on the grounds that intellectual property disputes might arise if one country stored a significant amount of its national germplasm in another nation's territory. The mine shuttered in 1996 when its thin coal seam was exhausted, and the seeds stored in 1984 are still there. And here is where Carrie Fowler enters my story. Raised in Memphis, Tennessee, Fowler has devoted his career to issues of social justice and agricultural security. He fondly recalls days spent at his grandmother's farm and tells me what it was like to be in the room when Martin Luther King Jr. delivered his "I've been to the mountaintop" speech. In the 1990s, he served the FAO of the UN and helped negotiate the International Treaty on Plant Genetic Resources. In 2005, he had just spent 3 years overhauling gene banks across the United States, and then Hurricane Katrina happened. Katrina for him was a reminder of how fragile life is and how quickly it is ruined. Waters rise, levees crumble, block after city block is abandoned to the elements. Katrina left Fowler wondering whether agricultural diversity could ever be truly secure when cities were vulnerable to geopolitical and ecological disaster. It was then that Fowler recalled the Norwegian scientists whose failed proposal for a gene bank in a coal mine had crossed his desk years earlier while he was working at the FAO. Back then, he had nixed the proposal, but now a vault dug into the permafrost beneath Plateberget seemed as safe a place as any, and indeed safer than most. The Svalbard Global Seed Vault, which is colloquially known as the Doomsday Vault, broke ground soon thereafter. The day I go looking for the graves of Spanish flu victims, Fowler gets in touch and invites me to join him at the seed vault. He picks me up the following morning, and we drive out of town, past the airport, and up a mountain pass leading to mine number 3. As Fowler and I ascend the mountain, a small herd of reindeer forages dispiritedly on a few hardy lichens, and Fowler points out an Arctic fox peering down at us from a roadside crevasse. A thin cement wedge piercing the frozen mountainside at a steep incline, the vault's brutalist exterior suggests how deeply it is lodged beneath the earth. Above the doors and along the roof is an installation of prisms and fiber optic cables that reflect the midnight sun in the summer and glitter like the aurora borealis during the polar night. It looks like a science fictional post-apocalyptic bunker, which I suppose is exactly what it is. Conspiracy theorists about the vault swirl among citizens of Svalbard and citizens of the internet. So some claim that it is secretly owned by Monsanto. Others whisper that it is a secret base for NATO. Rumors circulated for a time that it was built in preparation for the end of the world in 2012, as was foretold by misreadings of the Mayan calendar. One ongoing theory is that the vault is part of a eugenics experiment in which 1/2 of Norwegians will be sustained underground as the rest of the global population is decimated, so that they may later emerge to repopulate the planet with their Nordic genomes. Now, at first, the Doomsday Vault seems to keep evangelical time. That is, millennial anticipation oscillates between apocalypse and salvation, usually with nothing in between. Millenarians either welcome Doomsday with open arms, or they stockpile beef jerky and Bitcoin, and sometimes they do both. The point is that for them the end is nigh, and the present is reduced to a horizon in which to anticipate the end of days. This notion sounds somewhat like Walter Benjamin's point about perpetual catastrophe supplanting dialectical history. And more importantly, it is also the pervasive attitude of our times. Just turn on the news. The doors slam heavily behind us, and we face a long hallway, which is really a tube of corrugated metal sloping downward into the mountain. Everything is duplicated: ventilation, backup generators, and pumps. Now, there's no reason for one water pump, let alone two, in a hole beneath permafrost, but the building's designers have prepared for a time when the permafrost has thawed. Engineers planned ahead in other ways as well. Surveying the mountain, they ensured that the vault is nowhere near a coal seam. They worried that a century or more from now, when the vault is forgotten, miners might return to this mountain and inadvertently drill into the vault, seeking coal seams. They also accounted for a 70-meter sea level rise, which is a rough estimate of what would happen if all the glaciers in the world were to melt. Then they compounded that scenario with a tsunami and built the vault a full 5 stories above the predicted waterline. Engineers now calculate that given the current rate of climate change, the vault would remain below freezing even if the electricity were out for the next 200 years. So how long did you build it to last, I ask? And Fowler says, essentially forever. That is, he's designed the vault to be immortal. Fowler unlocks another pair of heavy doors. This next room is my favorite one. My twinkly-eyed trickster guide is the Willy Wonka of the eschaton, and the room into which he escorts me next is wondrous. A stark and cavernous antechamber of raw limestone, hollowed into vaulted ceilings and washed in white cement, the rock rimed in frost. I really enjoy being here, Fowler murmurs, and his voice reverberates. The wall directly opposite the doors from which we entered is gently concave, and to our left there are 2 doors offset, and a 3rd door is on the other side of the parabolic bare wall. And Fowler explains to me that they didn't put any of the interior chambers directly opposite the door leading to the hallway, so that, and this is a quote, if someone were to fire a missile down here, it wouldn't hit the place where the seeds are. So too, the wall is concave so that shock waves from, for example, a ballistic missile or a plane crashing into the mountain can reflect back toward the entrance rather than propagating deeper into the mountain and injuring the seeds. Salvage ethnographers and salvage biologists have for over a century been allied in their efforts to capture and preserve endangered cultures, species, plants, seeds, blood, languages, and ecosystems before they disappear. In this sense, I have the uneasy feeling that, at least from a disciplinary perspective, Fowler and I might share much in common. Indeed, Bronislaw Malinowski inaugurated ethnography's project when he was stranded on the Trobriand Islands during World War I. In the first sentences of Argonauts of the Western Pacific, he identifies ethnography's origin within the tragedy of history. So he writes, ethnology is in the sadly ludicrous, not to say tragic position, that the very moment when it begins to put its workshop in order, to forge its proper tools, to start ready for work on its appointed task, the material of its study melts away with hopeless rapidity. When men fully trained for the work have begun to travel into savage countries and study their inhabitants, these die away under our very eyes. 100 years later, biologists bank on similar notions of endangerment and decay to frame their scientific enterprise and to jumpstart a sensibility in which freezing can arrest the endangered past, here a global agricultural heritage that is at risk of liquefying and melting away. The door to vault number 2 is overgrown with frost, which has crystallized around the door frame and bloomed across the door handle. 806, excuse me, minus 18 Celsius is a sucker punch, yet here is abundant life. 860,000 different varieties of crops and 120,000 different strains of rice alone. Seeds are sealed in these triple-ply puncture-resistant vacuum packaging and then loaded into plastic crates, which are stacked on shelves. Looking inside one box, I find ampules of squash and bags of anise. Every major crop in the world is in this room, not just wheat, oats, barley, potatoes, lentils, soybeans, and alfalfa, but also heirloom seeds and forgotten land races. Boxfuls of foraged grasses are stored cheek by jowl alongside sorghum, foxtail millet, burr clover, purple bush beans, pigeon peas, Kentucky bluegrass, and creeping beggarweed. Every country in the world is here, as are several countries that no longer exist. Colombia, North Korea, Russia, Taiwan, Ukraine, Switzerland, Nigeria, Germany, Israel, Syria, Zimbabwe, Tajikistan, and Armenia share shelf space in this pastoral League of Nations. With over 90 million seeds deposited in the bank, India represents the greatest amount of crop diversity, nearly 3 times as much as Mexico, which is the next most prolific contributor. On February 26, 2008, the day the seed vault opened, Pakistan and Kenya were waiting in line to store their seeds. The previous year, the disputed election of Mwai Kibaki in Kenya triggered ethnic violence against the Kikuyu. Karachi had catastrophically flooded and was seen to a bloody suicide bombing, and Benazir Bhutto was assassinated in Rawalpindi. Perhaps for Kenya and Pakistan, a cache in the seed vault is a way to refuse political and climatological vulnerability, or to forecast a future that might sustain life. One shelf of the vault is half empty. 4 years into the civil war and humanitarian crisis in Syria, violence barreling northward toward Aleppo jeopardized the headquarters of the International Center for Agricultural Research in the Dry Areas. The acronym is ICARDA. Hundreds of thousands of seeds were banked here, including some of the earliest strains of Levantine wheat and durum, which are more than 10,000 years old. Now, in a Syrian summer, a power outage would thaw these seeds much faster than would one in Svalbard, so ICARDA shipped seeds to Svalbard for safekeeping. The Syrian Gene Bank, which is now relocated to Morocco and Lebanon, recently requested 30,000 samples from its original collection to help rebuild the country's stores of barley, lentils, and chickpeas. The millennialism of the vault is undeniable, as I've already discussed, but I'd now like to circle back to the 1918 flu to consider again how coldness refashions the temporalities in which life lives. Like the viruses and ruins that are thick on and under the ground in Svalbard, the vault is a condensation of multiple temporalities. These are places in which some subcutaneous latent life, whether coal or virus or seed, erupts into the present or is buried for future use. Coldness synthesizes and reassembles biological time. Following Deepesh Chakrabarty, latent life in Svalbard is a sort of time knot that refers us to the plurality that inheres in the now, the lack of totality, the constant fragmentariness that constitutes one's present. Medievalist Carolyn Dinshaw reminds us that in such a synchronous or heterogeneous presence, different time frames or temporal systems collide in a single moment of now. And I'm here alert to Dinshaw's demand that we must take seriously lives lived in other kinds of time. Indeed, latent life is precisely that. These forms of latent life are heralds of a fuller, denser, more crowded now that are out of sync with the ordinarily linear measurement of everyday life. Or, to borrow the language of anthropologist Kath Weston, latent life doubles back upon a future until the track that led to modernity begins to turn cyclical and elliptical in unexpected ways. Soon, Fowler and I are back outdoors. He marvels at the irony. He says, "We've got the largest collection of agricultural biodiversity in the world here, where there aren't any farms or gardens or trees or even an outdoor plant." Looking at the barren landscape around us, I nod, because up here, it looks like nothing is alive. Joy Williams, with whose novel, The Quick and the Dead, this talk shares a title, asks, what is the difference between being not yet born and having lived, being now dead? Do you believe that what has been is also now, and that what is to be has already been? Though the story I've told tonight centers on Svalbard, the forms of latency that I found here were embedded in one single mountain. Plateberget is home to an abandoned cemetery. Cemetery is here. 2 coal mines, that's one, and then the other one is here, and a seed vault, which is up there, and little else. Gruva is the Norwegian word for mine. It's the same word as grave, as both come from the Old Norse, and my Old Norse is terrible, but gruf, meaning cave. Plateberget is full of vaults and faults and graves and caves. The mountain has become a place to unearth coal and to bury coal miners, to immortalize seeds and to resurrect viruses. And one way to think about this is that the 1918 flu is a specter of the past that has erupted into our present, while the ruins of coal mines are persistently and always in the present. And the seeds in the Svalbard Global Seed Vault are artifacts of the present that are buried for future disinterral. Now, in his History of Animated and Organic Things, Spiros Papapetros, this is a great book, by the way, traces the ways in which animation infuses vitality into things not properly alive. So the examples he uses are things like modern art, technology, and architecture. So what I've presented here is in some ways an obverse of Papapetros' project. It's a history of organic inanimacy. And I suggest that the temporalities in which things on Plateberget move or don't move, and the speed at which they do or do not do so, is itself a principle by which things transition from life to immortality. Some life is slower than molasses on a snow day. Some life is stuck in the past, and much of that old life is durable in its endurance, perpetually present in the present. It lags and it persists. It can be patient as a saint and quiet to the point of cryptic. This points us to the possibility that rather than being the common denominator underlying all living things, life is perpetually a problem, one of temporal discontinuities. Viruses, ruins, and seeds that are stilled in states of suspended animation are classed as only problematically alive, but not quite dead. Biding their time awaiting reanimation, they are pervaded by a potent and vital potentiality. Thank you. So I'm going to field my own questions. Yeah, David.
So that was really, really interesting and lovely images. Thank you. So one One term I didn't really hear you use, or use much at least, is information. And it struck me as you meditated on ideas of definitions of life and temperature, that information and entropy seem to be really present in the background of your story, especially if we think that one 20th century definition of life is as information, and of course energy is required to maintain life or any complex system. So I guess the reason that I was thinking about information and entropy is because people often say heat death of the universe will be when information finally essentially dissolves. But in your context, cold is a suspension of processes, entropic processes that would cause information to decay. So my question is two little parts. The first is could you say a little bit more about information? But secondly, concretely, it seems that the project of Svalbard and salvage ethnography and anthropology and biology of all kinds is the preservation of information. But what strikes me, and it also strikes me when I think of, say, Joanna Radin's work, is how people really still want the thing. I mean, you could make an argument that you could just sequence the genomes of all the seeds or whatever and put them in a computer, but people still want some tangible remnant of the thing itself. And I just wondered if you might say a little bit about why the thing itself is still important in projects like the Svalbard Seed Vault.
Yeah, absolutely. Thank you for both of those questions. So I would say that information is still worth paying attention to. I think it's become worth paying attention to again. And what I mean by that is, as you said, if you look at the mid-20th century life sciences, they're a field that has been very much about thinking about life as information. Now, obviously, as you know, the idea that life is information is a metaphor. And if you follow what Lily Kay says in Who Wrote the Book of Life, it's actually a metaphor for a metaphor. So it's not just about information as a kind of conversation, but it's actually about syntax that lacks semantics. So in that regard, I think that mid-century moment is very much attached to the kind of thinking that came from physics, and here I'm thinking, of course, of the work of Schrödinger, which tethered the two terms that you queried, right, energy and information, to one another. So thinking about entropy became a way of thinking about how much signal is in information. And I think when you start doing that, you end up falling back on the assumption that I'm trying to undo here, which is about the relationship between form and matter. Because one of the ways that biology has been conceptualized in the years since Schrödinger's work, for example, is by claiming that matter doesn't matter if it's all information, right? It's precisely the kind of narrative that you were offering, was that, well, if you can sequence it, then you don't need the seed, right? And that's got its own historical story. Cool, so dessert? Or Hari?
Two-part question. You quoted the journalist saying that essentially that the life-non-life distinction has no basis. Are you sympathetic to that point of view? And the second part would be what do you think the cultural consequences would be if we did abandon that simple kind of common garden, living, non-living opposition?
Well, I mean, the second part is faster. If that did happen, I'd be really excited to ethnographize it. But with regard to your first question, I would say I agree with the journalist to a degree. What I mean is, life is a concept insofar as it is a historical artifact and category that has been carefully crafted by life scientists, but also by many people who have nothing to do with life sciences, and that gets built into their practice, right? So theories of life are things that people make. But that doesn't mean that it doesn't matter, right? Because as an anthropologist, all I care about is actors' categories. So this is one that's particularly rich and interesting. right? In the way that anthropologists have also thought about all sorts of other really rich and interesting categories like race and gender, which are also categories but are fun to think about and difficult to live with. Ahmed?
Thank you so much, Sophia. This was really great. I think one thing that that I probably saw throughout the talk is also a discussion of time and how time is impacting life. So I want to ask if you can say a little bit about the changing perceptions of time in with these actors, how they see the relationship between life and time. You moved brilliantly between historical moments about a century ago or more, and then the very concrete contemporary events that sort of punctuate the preservation of particular seeds. And it seems that there is a play on time scales and different time scales in understanding life. So this is not really a concrete question, but I wonder if you can say a little bit more about this connection between life and perceptions of life and this understanding of time and time scale.
Yeah, I mean, I could riff on it a bit. So one thing that probably became clear with regard to both the virus story and the seed story is that these are very Judeo-Christian conceptions of time, right? This is all about death and resurrection and the end of days, doomsday, like all of that is part of the narrative. So this is a, like I already said, it's very millennial, but it's also a linear way of thinking about time. And one of the things that I'm trying to figure out how to do, and maybe someone in the room can help me do this, is trying to write against these linear ideas of time, which, I mean, we've seen a lot of good critical theory in the last 20 years that have been playing around with that, right? I'm thinking of the work of Jameson, for example. But despite that fact, I think there is an assumption that that kind of time still works for biology and for accounts of biology. So we're very comfortable saying, we're no longer thinking about, these grand narratives, and we're going to focus on punctuation and short time scales, and we're all very postmodern, but then biology becomes about generations and reproduction and inheritance. And I don't think that's been the story for biology for a long time. I mean, this is something that Hannah Landecker herself discusses, but it's always about speed, not always about the actual way in which to think about the materialization of time as it proceeds in the moment and how it's being produced by scientists. So that's kind of a hand-wavy response toward what I'm thinking about next. Spiros?
My question is about visibility of what's called the latent living and design. That is, what are the aesthetics, in fact, of the latent life? If, as you
Sorry,
said,
could you repeat that last part?
The aesthetics.
Oh, the aesthetics.
Life. If, as you said, a lot of thinking about life is about life-likeness, explicit simulation, external simulation through movement of life, right? Mistaking life for the moving. What is precisely the image of life given precisely by what you call the latently living? I was struck by the three examples, the three sites today, the cemetery, the coal mine, and the Millennium Vault, right? Which they have a very almost borderline connection to visibility. As you said, you couldn't even see the crosses in that cemetery. They're all underground. You mostly cannot see them, or you're not sure that you want to see them. And with this, you have this huge construction underneath this little vault or whatever it is that is visible. But the degrees of design in all three were completely different. For example, the newspapers, as you said, that they wrapped the bodies versus an extremely elaborate, sophisticated construction that you had in the Millennium Vault. But so, to me, it's very interesting, not just as an architectural historian, the radically different understanding of the visual in relationship to what you call the latently living versus the animate that is.
That's a really good question. I'm going to have to spend some time thinking about it, but one thing that I would mention first is that another way to talk about latent life, and this was discussed at a workshop at the Royal Academy in 1952. They coined the term cryptobiosis, which means hidden life. And they had many different examples of it. Before, the term was typically latency, and cryptobiosis took over as a way of talking about anabiosis, hibernation, desiccation, all sorts of different ways that you could stop or pause life. And with regard to hiddenness, I would say that in some cases, latent life is kind of appearing or masquerading as something that's mostly invisible, but there are as many interesting stories about people thinking that there's latent life everywhere, and then it actually isn't. It's so one example that I find really interesting is the work that was done by Huxley on the Urschleim, right, where he said that he had found the sea mucus from which all life had sprung, and it was clay. But this happened all the time, right, at the end of the 19th century and into the 20th century. The latest example of Urschleim I could find was in 1907 or 1908, right? So the story there was that actually it's so latent that it's everywhere, and we haven't even seen it yet because we weren't paying attention, right? So there's this constant kind of figure ground move between things that are really, really apparent, which actually aren't alive, although they could have been, right? And then these things that are latent and totally invisible, or at least mostly so. And I don't know what kind of aesthetic that is, but I'll come up with a term for it and put it in quotes. Noam? Oh, sorry. Corinne? Or...
So you told us to think about the opposite of life not as death, but immortality. So do you have any comments on, I mean, this is sort of the obvious question maybe about immortality has been sort of the purview of religions. So do you see this perhaps as offering some kind of comfort as religions have, or perhaps also as religions have the site of cultural production?
Comfort. Well, comfort to whom? One of the things that I mentioned in passing was perhaps this is something that, soothing isn't the right word, but that this is a way of people thinking about insuring against certain kinds of ecological disaster, right? Well, the seed is in the vault, so somehow it's secure and protected. In that sense, yes, I think it does serve that kind of function. But I think, you know, modern biology, as it's been practiced in Western Europe and the US, has been so Judeo-Christian for so very long that I'm kind of surprised there haven't been more discussions of immortality sooner. I mean, the Royal Society was freezing ox brains and then trying to thaw them and bring cows back to life. So perhaps, you know, as long as there's been modern science, people have been trying to revive the dead. But I would say that while the discourse is religious, I'm not convinced that the sort of emotional terrain or kind of emphasis is theological. Does that?
Yeah, just the notion of immortality, that was what I was trying to get at.
Yeah, no, I mean, I found plenty of examples of dead fish being compared to Jesus, and then people try to revive them in their Victorian drawing rooms, and it usually doesn't work, but yes, the connection is there, at least rhetorically. No one was raising his hand, but...
Thanks, Sophia. That was just absolutely fantastic. But there's something special about this island in particular, right? I mean, this is a place, this is, if not the northernmost inhabited point or something like that, it's a place where dreams have gone to take off and to die and to be resurrected even earlier than even earlier than the flu. The earliest case I know is Andre's balloon expedition, right?
It was 1917, yeah.
Is it 1917? Okay, so
I'm fresh from the Svalbard North Pole Expedition Museum, so...
Okay, so you saw that, yeah. And you know as well that he designed the largest balloon that had ever been made, and they took off from Spitsbergen and disappeared, and 80 years later they found their bodies.
It was actually in Nyalazend, that mining town that now has the cabins for each research country.
Fantastic.
Yeah.
So it's great to see this island here again in that way. And I'm wondering a little bit about the kind of cultural symbolism of this island in particular. I mean, you've chosen a particularly charged kind of palimpsest with these, literally buried layers of history that you can excavate. But there is something sort of special about the mythology that this physical place embodies and captures. And I'm wondering if you could speak a little bit about that. I mean, there's a kind of like an end of the world-ness to this, no?
Yeah.
Tip of the world.
Tip of the world, end of the world. The
Yeah.
days, right? End of the world, both temporally and spatially.
Yeah.
Yeah. So, right, Svalbard is an archipelago. Spitsbergen's an island. One direction that I want to go in next, and this is a word that I learned from Roxani, thalassography. Yeah, okay, good. Which is the study of oceans, but she gave this masterful talk about thinking about islands as certain kinds of spaces in which to tell histories of larger kind of global shifts over time. And so I'm wondering whether there's a way to wrap Spitsbergen into that way of thinking about not just like limit cases, but yeah, places that are very not just distant but peripheral, and how they end up becoming almost sentinels for places that are much more central, right? So, the story about climate change is a really obvious example of how Svalbard is a sentinel for the rest of the world. But I think there are other ways to do a history around that place that would make a similar kind of claim.
Have you ever considered a product of this research that might not just be writing? There might be something physical, some installation, some intervention.
I don't understand what you're talking about now.
No?
We'll talk about it later.
Okay. Because it seems incredibly ripe for intervention as well.
Thank you. Maybe I'm not going to run the questions anymore. There's so many hands. I don't. You, sir. Yeah.
I was wondering when I was listening to you, how would a person, an anthropologist, if that existed already 200 years ago, describe this story which we heard tonight?
How would an anthropologist describe the story?
But what I'm after is, how much is the knowledge of what you were talking about dependent on science, which has been developed since in the last 100 years, and how will one look at the issue 100 years from now, when science has developed further? Yeah, I mean, you are a historian, so you look backward, and you are not a futurist. Yeah, but
thankfully,
I mean, the issue I have is, how does man understand the issues you have been describing tonight 100, 200 years ago, and what will he see when we have more knowledge of genetics, for instance, of development? I mean, it's very static what you are saying. That is the knowledge of tonight, what we hear. Does it make sense, my question? How would one look at it? Would it be only theologically understandable 200 years ago?
I see.
Or was science there already which would come close to what you have been discussing?
Well, I don't think... My account of science, I would say, is descriptive, but I don't intend for it to be explanatory in any way. In that sense, right, my anthropological work is to describe, I mean, culture is a dirty word these days, but to describe human practices as I find them. And in this case, the human practice that I'm interested in describing is scientific, but I'm trying not to turn a scientific lens on the story as a way of explaining what's going on. Does that make sense to you? Okay. We could talk about it more at the reception. Stephen?
This is fascinating. There's something very pre-modern about this whole endeavor. It's almost a Noah's Archean. Noah put everything on. I mean, this isn't Darwin on the Beagle getting specimens to figure out patterns in nature and such. It's merely about preserving against some future catastrophe. And I'm wondering, do the scientists, but it's being done by scientists, do the scientists discuss that aspect of the thing? And the other thing, just logistically, it seems to me that if the catastrophe is that severe, there would be no way to retrieve anything from northern Norway at that point. I mean, northern Norway is actually quite far away from, I guess it depends on what survives where.
Yeah.
So I'm just sort of thinking through 100 years from now when the big one hits and how this all works out. Did the scientists discover it? Did they discuss this? Do they?
How it will be, or how the knowledge will be maintained, or whether people actually
how
have
they'll
access to
disseminate
this
it, how they'll be the Noah's Ark of and just also just how pre-modern it is. I mean, it's not really science except that they're using techniques to preserve.
Right.
But the endeavor
there are
itself is not
many
particularly
examples
scientific.
of science before the modern, and this is kind of a live discussion in history of science. I've never heard a scientist pat him or herself on the back for being pre-modern. But
isn't it like Noah's Ark?
Well, Noah's Ark didn't happen.
The story.
So it's not really.
I mean, they're perhaps inspired by it.
Well, so one thing I would say about that is there's a very long history in science, both pre-modern and modern, of collection, right? So before we had the laboratory, which is pretty recent, the way science got done was by gathering things and looking at them and comparing them, right? And this was, you described Darwin's work on the Beagle. I mean, this is a story that's familiar to many people, but what most people don't think about, except for historians of science who think about this way too much, is that the kind of experimental method that we consider to be almost definitional to science now is really, really recent in the historical past. So they're not doing this kind of work for research purposes per se, but they are thinking about this as a kind of gene bank in the way that we have gene banks and blood banks throughout the 20th century that will be used at some point both to rebuild seeds within countries, and they're kind of oriented toward the future, thinking about something more global.
Jurassic Park.
That was my first book.
Oh, Eric. This was really fascinating. One of the things that I found thinking about the structure of the talk itself is that the first example that you have is about resurrecting the past. And the second example is perhaps about the circularity of the present. And the third example is about planning for the future.
You're listening really carefully, that's good.
Yeah. So there's a way that the latency of life develops chronologically in the way that you've presented them. I mean, temporally, not chronologically, temporally. But I wonder, there's something about, and this is a vague question because I haven't quite been able to put my finger on what it is, but there's something about the way that you've presented it that makes it seem like life is put on pause. That latent life is not full life. And yet, these organisms, in order to make this move from the past to the present, from the present to the future, that there has to be a kind of extremely slow life rather than a pause on life.
Right.
And one of the things that makes me think this is, Rob Nixon has published this book called Slow Violence that's about the ways in which anthropogenic, how do you dramatize something like anthropogenic climate change that takes so long? How do you make people pay attention to the drama of it? And there's something that I think you've actually captured in a very interesting way how to do that. But I'm curious about this question of really, really, really slow life as opposed to latent life.
Okay, so you're saying that latent life is actually just stopped. And what I'm describing, I'm not quite going all the way to saying it's stopped completely, but it's just kind of creeping. Is that, am I getting it?
Something like that. I mean, yeah. or there's something maybe about the term latency that feels like it implies stopped.
That's right. Yeah.
When actually, I think maybe you're not really talking about stopped.
So, wow, okay. For the people, the scientists in the first and third story, right, the Canadian epidemiologists, molecular biologists, and then the people who are running the vault, that's the way in which they described to me what they were doing, or the way in which I saw them describing what latency is in peer-reviewed papers. But I've started reading some really weird theoretical biology, and there's a whole raft of literature that says that actually latent life is not just stopped, but basically dead. And that means that death isn't a thing either, because you can't really tell whether something is latent or dead until the moment after it gets revived.
Schrodinger's life.
It's Schrodinger's life, yes. Good, I'm going to use that. I hope you don't mind.
Yeah.
So in that sense, very much stopped.
Okay.
Yeah.
Thank you.
Short question. How is it ensured in the vault that in future times, when they open it, given a catastrophe happens, you would actually know what to do with the seeds? Is there a universal language constructed which helps identify these things? Or?
That's a good idea. No one has done that. And actually, I was surprised by how little work beyond the design of the vault had been put into thinking about the question you just posed. When I asked about, for example, they showed me the database, which is online. I mean, you can go online. It's open to the public, and you can see which land races there are, which strains, where the seeds came from, how many are available. Like that entire database is open to the public. And I said, well, global catastrophe 200 years from now, no one's online, potentially. And the response was, well, we printed it out and left a copy in the vault. So, right, some technologies are simpler than others. I don't know what else to say about that.
Sophia, thank you.